The End of the Universe, Part 2. As discussed in Part 1 of The End of the Universe, everything has to end. We took a dive into some popular theories on how and when the universe could end. After discussing the Big Freeze and the Big Rip, we'll now continue to discuss how the results depend on how the values in the next three models are changed. The Big Crunch. It's possible that the universe may ultimately terminate in the other direction, changing its trajectory and collapsing in on itself in a manner known as the Big Crunch. Scientists often stack the deck in favor of dark energy in the cosmic tug-of-war between gravity's attempts to draw everything together and dark energy's attempt to push everything apart, which would eventually result in a big freeze or a big rip ending. However, we can't entirely rule out the possibility of gravity. If the universe's matter density is great enough, its gravity may override the expansion and start a contraction phase. As the universe shrinks again, everything will start to migrate towards everything else. Anyone living at the time would not be immediately impacted, at least not until close to the conclusion, similar to our present growth period. Stars would soon collide more often as galaxy clusters, galaxies, and finally individual stars began to fuse. However, the cosmic microwave background or background radiation of the cosmos left behind from the Big Bang is where the real danger starts. This radiation warms up when its photons are moved towards the blue end of the spectrum, ultimately becoming hotter than stars. As a result, the stars will continue to heat up until they evaporate, since they are unable to radiate heat anymore. The cosmos would reach its maximum temperature in the last few minutes, which would cause atoms to disintegrate. They won't have to worry about it for very long, since they will be dragged into black holes, which are consuming an increasing amount of the cosmos. One day, the universe's whole contents will eventually condense into a singularity, which is similar to a backward Big Bang. When this contraction phase may start is estimated differently by various scientists. It may not happen for billions of years, or in terms of the cosmos, it may happen pretty soon, since the universe will reverse its trajectory in around 100 million years, according to a new research. Before we return to the singularity in that paradigm, the contraction phase would last for almost 1 billion years. The Big Bounce. However, things may not yet be over. According to a variant of the aforementioned theory, just as the universe is about to collapse into an indefinitely dense singularity, it is spared by quantum processes and changes direction once again, starting a new phase of expansion that is essentially a second Big Bang for a completely new universe. The Big Bounce is the name of this design. Proponents of the theory claim that there is precedent for their hypothesis in the field of quantum physics. After all, as the universe approaches a singularity, it gets so small that quantum rules supersede the large-scale classical physics we're accustomed to. When that happens, quantum tunneling may take place, allowing particles to pass through obstructions that, by all logic, they shouldn't have the energy to do so. This is what drives processes like radioactive decay and, in a recent research, may also be what enables a contracting universe to escape the doom of catastrophic collapse and start expanding once again. It's interesting to note that loop quantum gravity, a theory developed to explain gravity in terms of quantum mechanics, provides support for the Big Bounce. The Big Bounce idea has the amusing implication that we may be in the midst of an endless series of worlds being produced and destroyed. The Big SLURP. The last possible end-of-the-world scenario on our list is maybe the most terrifying, since it might already be bearing down on us and we wouldn't know until it happened. The Big SLURP, or a false vacuum decline, is the most common name for it. A system will naturally want to become stable. This is a physics law. To achieve this, it transitions from a high-energy state to a low-energy one before stabilizing in its lowest possible energy state. This is what is referred to as the vacuum state for quantum fields. All known quantum fields are believed to be in their stable vacuum states, with the exception of the Higgs field. It looks to be in a false vacuum state, which indicates that while it is not expected to be in its lowest energy state, it is now stable. But anything might suddenly change. The Higgs field might abruptly transition into a lower energy state, wiping out a sizable portion, if not the whole universe, in the process. All that would be required for a vacuum decay bubble to begin growing at the speed of light would be for one small point in space to fall into this lower energy state. We weren't even able to see it approaching since it was moving so quickly till the wall of that bubble crashed into Earth. Once we are within this bubble, what happens? It will undoubtedly change the natural laws, but no one is actually sure. Under these new physics, there is a possibility that life may exist, but the cosmos may be so drastically different from our own that we're unable to even conceive it. In the worst situation, everything is destroyed. The premise is fraught with ambiguity, which is good news if there is any. According to certain simulations, false vacuum decay won't likely happen for many billions of years, or it won't be feasible at all. Others contend that it ought to have occurred by now, suggesting that the bizarre new physics within the bubble may possibly constitute the basis of our present universe. It's also possible that the Higgs field is more stable than we realize. After all, the Higgs boson's discovery was just very recently proven, so there is still plenty to learn via more research. Or maybe the sun has just been absorbed by the artificial vacuum bubble, which will arrive in 8 minutes.